Hello everybody, and welcome to exercise 1 on page 137 of the workbook. And this is our first example of actually taking a function and calculating partial derivatives. Okay, so let's read the directions here. So they're giving us functions and asking us to calculate the first partial derivatives of each function with respect to both independent variables, which is going to be x and y for these first few examples. Okay, and the good news is, if you can calculate an ordinary derivative, you can calculate a partial derivative. The process is going to be very much the same here. So let's start with the function that they're giving us in part A here and see if we can calculate fx, the partial derivative of f, in the x direction. Okay, now the thing to remember when we take this derivative, this is the key. When we take the derivative with respect to x, we are treating y as a constant. That's the way partial derivatives work. So we're going to take the derivative with respect to x. All other variables are going to be held constant, so we're going to be treating the y, every y that we see, as if it's constant. Okay, so keeping that in mind, let's visit these terms one at a time and see if we can write down their derivatives. So first of all, we have 3x. What is the derivative of that with respect to x? Well, derivative of that's just going to be 3. And then we come to 5y. What would happen there? Well, remember that we're treating y as if it's a constant. Okay, so when you look at 5y, you have to think of it this way, that 5y is just a number. It's a constant. And what happens when you take the derivative of a constant? You just get 0. Okay, so that term goes away. And then we come to 2x cubed. Its derivative with respect to x is just going to be 6x squared by the power rule. And then finally, what about the last term, 4y cubed? Okay, well again, y is being treated as a constant, and so that entire term, 4y cubed, is just a number. We're treating it like it's a number, and its derivative is going to have to be 0. Okay, so putting it all together, the partial derivative with respect to x should be 3 plus 6x squared. There's our answer. Okay, and we're ready to move on to the partial derivative with respect to y. Okay, and there, it's exactly the other way around. This time, y is our variable, and we're going to hold x constant. Okay, so let's back up here and visit our terms one at a time again. So starting with 3x, what would its derivative be with respect to y? Well, we're holding x constant, so that 3x is just, we're treating it as a constant, so it should be 0. Then we move on to 5y, and since y is our variable, we should get a derivative of just 5 out of that. Then 2x cubed. Again, x is constant, so the derivative of that 2x cubed should be 0. And then we come to 4y cubed. There we should just get 12y squared by the power rule. Okay, putting that all together, it looks like our derivative with respect to y is 5 plus 12y squared. Okay. And we're done with part A. And again, the key idea is just remembering which variable we're treating as a variable and which we're treating as a constant. Okay, let's scroll to the next page and do one more example together here. Okay, so same instructions for this question. They're asking us to find the partial derivatives with respect to x and y. Okay, so we'll start with the derivative with respect to x. Maybe remind ourselves that when we take that derivative, we're holding y constant. Okay, so let's see. If we start with 4x cubed, its derivative, just by the ordinary power rule, is 12x squared. Okay, and then we move to 6xy squared. That's got x's and y's in it. Okay, so before we tackle that, I'm going to postpone that to the next step. So we're going to take the derivative of that with respect to x. Okay, same is true for the next term. We're going to take the derivative of that with respect to x. Okay, and then we come to 3. That's just a constant, so we're going to get a derivative of 0 there. Okay, so we've taken the derivative of the first and the last term, and what we still have to do is the derivative of the 2 in the middle. Okay, let's talk about those together. So far we've got 12x squared, and then we come to the derivative of 6xy squared. Okay, well, you might be looking at that and thinking there's a product going on, so maybe we need the product rule, but there's an easier way to think about this. Okay, and it kind of comes down to remembering the fact that we're treating y as if it's a constant. Okay, so what that means then is that when we take this derivative, any y that you see is a constant, and so we can pull it outside of the derivative. So for example, the 6 and the y squared, we can pull outside of the derivative. And just take the derivative of the x that's left over. X is the only variable in that expression. And similarly, if we move over to this derivative of 2x squared y, the 2 and the y are constant, and so we can pull those out. Oh, whoops, I'm sorry, I wrote that backwards. Back up a second here. Okay, the 2 and the y are constant, so we can pull out the 2 and the y. And all that's left to take the derivative of is x squared. Okay, so we're one step away here. So just rewriting what we've got, 6y squared we pulled out. The derivative with respect to x of x, that's just going to be 1. Okay, over here. Now we need to take the derivative of x squared. That's going to be 2x, and the plus 0 we don't need to write. Okay, so we have worked our way down to a final answer that looks like 12x squared plus 6y squared minus, and if we just simplify a little bit here, 2y times 2x is 4xy. Okay, and all of that should be our derivative with respect to x. Okay, what about the derivative with respect to y then? Okay, well, we'll start over again, and remember that when we're taking this derivative, we're treating x as if it's constant. Okay, so if we go back to our function, we're starting with the term 4x cubed. Since x is a constant, that should just go to 0. There are no variables in that expression. Okay, then we come to 6xy squared. Let's write that out in longhand notation. We'll hit that at the next step. So we need to take the derivative, with respect to y, not x. Okay, then we come to the next term. I'm going to postpone that to the next step. So we'll need to take the derivative with respect to y of 2x squared y. Okay, and then we come to the 3. That's a constant, so its derivative is going to be 0. Okay, and to finish this, we'll start off with the derivative of 6xy squared. And remember, y is the variable. So that means that 6 and x can be pulled out because they're being treated as constants. So this is going to be 6x times the derivative with respect to y of y squared. Okay, and then similarly over here, the 2x squared, that's being treated as a constant, so we can pull that out. And all that's left to take the derivative of is the y. Okay, and so let's see, simplify a little bit here. So we need the derivative of y squared. That's going to be 2y. And over here, the derivative of y, that's just going to be 1. So one last step of simplification. Looks like we're going to get a 12xy minus a 2x squared. And that should be our answer. Okay, so there's 2 examples of calculating partial derivatives, and now you've got a chance to maybe try a couple of these exercises on your own and see how they go.